All right, section 5.3, we're going to look at conditional probability and how do we figure out whether or not two events are independent. Okay, so when we're talking about conditional probability, we're talking about like two events, and if I know that one event has happened, that it might change the probability of the second event happening. The way you'll see this written in notation is B and then this straight up and down line. And so you would read this as the probability of B given A. All right, so here we have a two-way table that looks at the class that people were traveling in on the Titanic and then whether or not they survived. Okay, so our events that we're going to look at are F is a first class passenger, S has survived, and T is a third class passenger. So this first question, find the probability of T given S. That means find the probability that someone was a third class passenger given that they survived. Okay, so that means that we are only looking at people that survived. So we're only looking at this row. Out of the people that survived, what's the probability that a person was a third class passenger? All right, so that is going to be 151 out of 442. So when we have conditional probabilities in a two-way table, we're looking at just the row or just the column that comes second. That's that given part. We're no longer looking at the big total. Okay, so as far as format for your answers, you can write 151 over 442, or you can write it as a decimal. I would probably go to three decimal points though, if you do that. There is no need to simplify this fraction on the AP exam, and in my class, you'll get full credit for an unsimplified fraction as well. And then when we interpret that, remember we're only looking at this data. So we would say, given that the randomly chosen person survived, so we're always going to start with the given part. There's about a 34.2% chance that they were a third class passenger. Okay. Sometimes we don't have a two-way table, so that's when we can use this conditional probability formula. So the probability of A given B is equal to the probability of A and B, which we looked at in the last section, divided by the probability of B. Okay, so if we don't have a two-way table, that's another way we can do conditional probabilities. So here we have some information. 68% of people in an apartment complex use Facebook, 28% use Instagram, and 25% do both. So we want to know the probability, given that the person uses Facebook, what's the probability that they use Instagram? Okay, so we want the probability of Instagram given Facebook. All right, and so that's going to be the probability of Instagram and Facebook divided by the probability of just Facebook. Okay, so the 25% that do both, that's our probability of Instagram and Facebook. And then we divide that by the probability of using Facebook, and that gives us our probability that a person uses Instagram given that they use Facebook. All right, conditional probabilities can also help us determine if two events are independent, meaning one event does not affect the probability of the second one. And so we know that two events are independent if the probability of A given B is equal to the probability of A given the complement of B, or just equal to straight up probability of A. All right, so for example, let's look at the probability that someone has their ear pierced given that they are male. All right, so the probability of B given A is 19 over 90 or 0.211. Okay, so if these events are independent, then the probability of B given A, the probability that someone has an ear pierced given that they are male, should be equal to the probability of B, meaning that the probability that a person has a pierced ear. All right, but if we look, the probability of a pierced ear is 103 over 178, which is 579. So because those two probabilities are not equal, these two events, having a pierced ear and being male, are not independent. Okay. When we know that someone is male, it lowers the probability that they have a pierced ear. So these events are not independent. So we have some multiplication rules that can help us. This is probably a concept you're already familiar with. So if we know that 55% of high school students play on a sports team, and then of those students that play on a sports team, 6% of them will go on to play on an NCAA team in college. And so we want to know what percent of high school students play a sport and go on to play on an NCAA team. Um, you might remember this, that the rule that and equals multiplication. So if I multiply those two things by each other, the probability of both of them happening, it would be 0.033. Okay, and so this is our general rule. The probability of A and B is equal to the probability of A times the probability of B given A. This is the general multiplication rule because it always works. If we have independent events, the B given A part doesn't really matter because it's the same as the probability of B. So we can just say A and B is equal to probability of A times probability of B. Okay. So this is for independent events. It's really just simplifying the formula. Basically, what you should know is if we want to know the probability of two different things happening and both of them happening, we're going to be multiplying those probabilities. Okay. So again, we'll look at an example, all right, about teens that use social media and then feel pressure to post content that will be popular and get lots of comments or likes. All right, and so again, we want the probability of both of those things happening, so we're going to multiply those two probabilities together. All right, tree diagrams. You have seen these before, probably in middle and elementary school, but we are going to now add probabilities to them. Okay, so what does a tree diagram look like? Here we have a tree diagram for whether or not Shannon hits the snooze button, and then if she makes it to class on time. All right, so each branch has a probability listed. These are conditional probabilities because we know she hit the snooze button. So, like, given that she hit the snooze button, what's the probability she's on time? Anytime we make one of these, the connected branches, they could be two, it could be three or four out of one choice, but they should have a sum of one. All right, so here we have a problem. I want you guys to pause and read that because I don't need to read it to you. And so we're going to draw a tree diagram about what generation people belong to. And then in each generation, how many of them read ebooks versus print books. All right, so our tree diagram should look like something like this, okay? If we have a randomly chosen adult, they can be part of one of these four generations. And then in each generation, we're looking at, do they read more ebooks or more print books? And if you notice, like each one of our branches, these four branches together, the sum of them is one. And then each connected set of branches here also has a sum of one. All right, so the question, find the probability that the person reads more ebooks than print books. All right, so we need to know reads more ebooks than print books, but for each different generation. Okay, so what we're going to do here is I need to know what percent of millennials read more ebooks, Gen Xers, baby boomers, and matures. Okay, so for each of these probabilities, I'm going to multiply them. All right, so 0.34 times 0.2 gives me the probability that someone is a millennial who reads more ebooks. And then 0.22 times 0.25 gives me the probability someone is a Gen Xer that reads more ebooks. So we're going to do that for all four generations and add those probabilities together to get the total probability that I get any person that reads more ebooks than print books. Okay, and then second question we can type of question we can answer from tree diagrams is, suppose a chosen person reads more ebooks than print books. What's the probability that he or she is a millennial? So now we're doing a given, a conditional probability, okay? Given that they read more ebooks, what is the probability that that person is a millennial? Okay, so we go back to our conditional formula. The probability of millennial given reads more ebooks is going to be equal to the probability of millennial and reads more ebooks divided by probability of reads more ebooks. Okay, so that's our conditional probability formula from the very beginning of this video. All right, so millennial and reads more ebooks, okay, that's going to be 0.34 times 0.2. And then just reads more ebooks, that's that 0.2098 formula that we found in the last question. Okay, and so when I do this multiplication on top, I get 0.068, and then our division is 0.3241. So given that a person reads more ebooks than print books, there is about a 32.41% chance that he or she is a millennial. All right, and that's it for 5.3.